Okay, so we're going to go over our mole ratio stuff here. I'm going to go over a few bonus problems right here. So basically, the blanks here are just telling you the different ways that we can use a mole ratio. So the first one tells me, it says how many moles of one blank will be produced given number of moles of a blank. And this could be really anything, so I'm just going to fill in what we have here. How many moles of one product we will produce, a given number of moles of a, and I'm actually going to use, of a reactant. Okay. And then I read the problem, and it says how many moles of carbon dioxide, so that's where I'm ending, is moles of CO2, are produced when I have 3 moles of butane, which is C4H10. And it says are reacted in excess oxygen. Excess oxygen means it will not impact the amount of product we can make, so it means ignore. Okay. So 3 moles here, and then I look up here, that's a 1. So I have 1 mole of butane on bottom to cancel. And then CO2, oh, my bad, this is not balanced. That would be why. So there's a 4 here. Actually, this is going to be a 2. I'm going to start over. This is going to be a 2, which is going to be an 8 here. It'll be a 10 there. It'll be 16 O's plus 10 O's gives me okay, 8 20 H's. Need 10 there. That gives me 10 O's. Plus 16 is 26. That gives me, there we go. That's where my math went wrong. 13 oxygens. Okay, so I have 2 butanes, 2, how many CO2s? 8 moles of CO2. 3 times 8 is 24. Divided by 2 gives me 12 moles. Okay. Okay, the next problem says how many moles of one reactant we need to produce a certain amount of moles of a product. This time I want moles of O2, given that I have 10 moles of H2O. And again, I go look up here, H2O is a 10. So I have 10 moles of H2O. And on top I have 13 moles of O2, which gives me 13 moles of O2 as my answer. Next, I have a ratio of one reactant to another. This time I have 5 moles of O2, and I want to figure out how many moles of butane I need. So O2 from up here is a 13, and butane is a 2. Oh, it's going to be 5 times 2 is 10 divided by 13 is going to give me roughly like 0.6 maybe, something like that. Let me do quick calculator math. 5 times 2 divided by 13, 0.77. Last type of problem, and these aren't really that important as long as you know how to calculate them, is how many moles of one product we're going to make if I know how much of the other product I'm making. So here I have 4 moles of water, which is H2O, and I want to know how many moles of CO2 I am making. So I go and I look, I got 10 H2Os and 8 CO2s. So on bottom I'm going to put 10 H2Os and 8 moles of CO2 on top. 4 times 8 is 32 divided by 10 gives me 3.2 moles of CO2 as my answer. Now we're getting into the homework problems. So here it says XSP4, remember it means ignore me. So I got 6 moles of H2 and I want moles of pH3. So on bottom I have moles of H2, on top I have moles of pH3. Here that's a 4, and that's a 6. 6 times 4 is 24, divided by 6 gives me 4 moles of pH3. Here I got 6 moles of H2, and I figure out how many moles of P4 I need. So again, moles of H2 goes on bottom, moles of P4 on top. That's a 1 and that's a 6. 6 times 1 divided by 6 gives me 1. Now, one thing to note, and I'm going to answer these, is a mole ratio is used to convert to moles of one substance to another. So basically the identity changes. So if the identity changes, I need a mole ratio. Moles of one compound to moles of another, yes, I need a mole ratio. I'm going to name this 1C and this 2C. Okay, so you're going to have a number of 1C. You're going to have moles of 1C on bottom, moles of 2C on top, and I'll get my answer some number, a mole of 2C. Same compound means no. And here I'm going to use what we call molar mass, which we'll learn more about next week. Grams of one compound to moles of a different compound, the answer would be yes, because my identity changes. So I'm going to have grams of 1C this time, and then grams of 1C is going to have to go on bottom, and we'll find out later that this is how I convert to 1 mole of this thing. And then I have moles of 1C on top, bottom, and moles of 2C on top to give me moles of 2C, different compound. There. Okay. Here I have 2 moles of glucose, C6H12O6. So C6H12O6 is on bottom. I'm going to actually erase to give myself some more room. And on top I have H2O. How many H2Os do I have? I have 6. This is a 1 from right here. So 2 times 6 is 12, divided by 1 gives me 12. Okay. Here I have 4 moles of H2O. And on bottom I'm going to have moles of H2O. On top I want moles of CO2. CO2 is a 6, H2O is a 6, so they're both 6s. 4 times 6 divided by 6 gives me 4. And that's it. Let me know if you have questions.